Thank you.
So someone brought it to my attention that on the syllabus, it says we're having an exam today.
Oh.
Do you want to? So that sounds pretty terrible. That's not happening. Just heads up, we're not having an exam today, so no worries. But I would like to at least have the chance, like if you didn't do great on the first exam, to have a chance to like have this middle exam. Like there's two options here. One is we just say, fuck it, we don't have an exam, and we just have a final. That's one option. Another option is we have like a take-home kind of thing where it's just a problem set, you work on it and turn that in. But we can't afford another day of class or two. You know how my exams are like, we have an exam, then we got like a whole week of just exam stuff. We can't afford that. We have 9 classes left, including today.
That's it?
Joking.
I'm not joking. So, because we're taking off Great Wednesday before Good Friday. So,
Wonderful Wednesday?
Wonderful Wednesday, yeah. So we're only gonna have one day that week, and that's in 3 weeks, so, or 2 weeks. Yes?
I like the idea of a take-home exam before final,
I thought so too.
like an optional.
And then the final, an optional take-home exam?
Well,
Huh.
just throwing it up.
Like, I guess if you need it, you can do it. If you don't have to do it.
Like if you did bad on the first exam, you have like a chance to, I don't know,
Yeah,
improve. But
that's
if you
what
did
I
great
think
on the
too.
first exam, then you're not feeling.
Okay, yes, Hans, your input.
So my question is, if it's like 15, 15, 15 for all 3
Yeah,
exams right now,
yeah.
so would like the final and the first exam just take up like half of whatever 15 is?
That's one option.
Okay.
Yeah. So the other options are I change your exam total to like 30%, and then your homework total goes up to 70%. That's another option, which sounds crazy, but if your homework's turning out good, I mean, that's not a bad option. How about I like all these are all really good suggestions.
Make a poll.
What's that?
Make a poll.
I will make a poll. Yeah, I'll make a poll, send it out. We can figure it out as a group. Work together toward a common solution. Yeah. Okay, great. I also hear lots of things from my friend. And my friend also had questions on the problems that you got right now. Right, we got a problem set. Kendra, yes, you have a specific question, my friend?
I do. For number 6.
Doesn't look like you're alone. There's some pretty serious nods behind you that you couldn't catch.
Cool.
What was number 6?
You're given a 4th order differential equation solution.
Oh, okay. Yeah. Can you give me that?
Yeah, mine is y equals -5e to the 4x, x sine x.
Oh, like that, okay.
Yeah.
Oh yeah, I remember that. And then you come up with a DE that's the solution of, we did a couple like this at the end of the hour, right? So what is troubling you here? Just where to start, or would you like an example again?
I think I've gotten to like one, because it's 4th order, so there needs to be 4
roots, yes.
4 roots.
Yes.
So I found one part for 2 of the roots, but I don't know how to combine like the 2 roots over here and the 2 roots over here.
Yeah. Okay, so this only corresponds, just so you know, I see this is only one root. When I look at this, I only have one. And then there's a conjugate. So this is a complex pair. So let's do one that's kind of like this. Let's say we had y equals, and I'm getting myself into terrible trouble by what I'm about to do. Not like ethical trouble, but like mathematical trouble. So, oh shit, no, I swear, I'm gonna make my life really hell. That is terrible. That is just terrible, but I'll show you what to do. So, when I see this, first off, this corresponds to -1 plus or minus 3i. Right? So like you should be able to look at this and see that this corresponds to this x, you gotta move it out in front, right? Whatever, there was some number in front. The numbers in front are irrelevant. The coefficients are completely irrelevant. I see this and I see, what root did you think this was?
Me?
Yes, ma'am.
I put, well, there's the X under your hand, right?
Yeah, but that doesn't help get the main root. That's repetitions of the root.
Okay, so it's 4 plus or minus I
Beautiful.
with multiplicity.
And then multiplicity 2. Yeah. Oh, I see your problem. Okay. Oh, no, it's actually good. It's all good. So this one is, what multiplicity is this mass beast?
3.
3. It's a third multiplicity root. So we have lambda. Let's talk about how this is going to work. I'm going to have lambda in this. Okay, so let's put here multiplicity 3. Is everybody cool on that before I even go on? Make sure you see that, because if that doesn't work for you, none of this shit's going to work for you, Hans.
Sorry, can you just remind me, what does like multiplicity of 3 mean in the context
That
of the
means,
problem?
so like for example, if I had lambda minus 2 squared, and I was looking at this polynomial, which is lambda squared minus 4 lambda plus 4, I would say 2 is a root of multiplicity 2. It's repeated, it's the amount it's repeated in the product. Does that make sense?
Mm-hmm.
Okay. So then this guy here, multiplicity 3, that means I'm going to have a lambda minus -1 plus 3i cubed. And I'm going to have a lambda minus -1 minus 3i cubed. So that's one way to look at this, but it's not the best way to get a pretty answer out, the fastest way. So you could like do all this, it's going to be not fun. But what I would do is rewrite this as conjugate pairs. So in other words, I'm going to rewrite this as this cubed. So lambda minus -1 plus 3i and lambda minus -1 minus 3i. Yeah, I guess I do want that. Why do I want that? Because when I multiply these two together, things turn out pretty. So this times this, the outer and inner terms turn to a real number. And you just got to kind of do it a couple times to believe that, but this is going to be lambda squared for first. The outer is going to be, let's just go ahead and write it out so you can actually see it. I'm going to distribute the minus, so it's 1 plus 3i lambda, that's your O, right? And then your I is going to be plus 1 plus minus 3i lambda. Notice how the 3i's cancel. You can see it right there. It shows up really nicely. The imaginary stuff will cancel if you always do a root and its conjugate as the parts of the things you're foiling. And then the last one, this will turn into a real number. So this might be causing some troubles. I've got -1 plus 3i times -1 minus 3i. Foil that. First times first is 1. Outer and inner are going to cancel. I'm going to get positive 3i outer, negative 3i inner. That will always happen for a complex number times its conjugate. And then that times that is -9i squared. That's -1. So that's plus 9. So 10. And then that's all cubed. You can see why I'm probably not going to like keep going with this. But I will finish the center up. It's going to be lambda squared plus 2 lambda plus 10 cubed. And then I would actually have to like multiply that out and then convert it to a Diffie cube. Does that make sense? So over here you'll get, something squared. And it'll be some lambda, some beautiful, nice polynomial, and then just square that with long, I don't quite know what it's going to be, but, do this game here, multiply the polynomials. You'll get a lambda to the 4th. Like, let's just say I did this. I'm making up what I'm about to get out here. This is not real. This is not real camera. This is not real people watching this. But if I came up with this, well, clearly 4 is going to be in there. And then let's just say that's, nope, just 1. Multiply it all out, and then this converts to a Diffie cube as 4th derivative plus 7, 3rd derivative, plus 2, 2nd derivative. Does that help? Looks like it helps a lot. Cool. Gut. Yeah. I don't know why I became German all of a sudden.
You find the roots, like just like a breakdown of like steps for doing this backwards. You find the roots and then make it into a characteristic polynomial, and then simplify a bunch, and then turn it back to look like that.
That's it.
Okay.
That's it, Ella.
When you say the roots multiply by 3, is it because of the x squared and the 7?
It's just because of the x squared. So the only way I get x's, the only way x's show up is through repetition of roots. If I saw that, then I would say, oh, it's -1 plus or minus 3i, just that root pair.
Right.
If I put x here and any number in front, now it's been repeated once.
Oh, okay, so if it's x squared and it's repeating 3 times.
Yep. That's right. Good stuff, good discussion. Good. Okay. Other questions on that homework? I want to work like one, because I feel like some folks have not tried. Grace has got a great question for me, I'll bet.
No, it's just on mine for
You don't think it's a great
problem 6.
question? I bet it's a great question.
So I did all of that and I got the right answer, which was right, but then when I found the general solution for the differential equation, it did not.
Oh, do we have a web workout too?
Yeah.
Oh my goodness, well, I'm the real bastard, aren't I? I really make you all work a lot. So can I take a look here real quick? So
Yeah.
Grace is asking about web work, number 6, problem 6.
That was the one that we were just doing.
Oh, it was, oh, okay. Oh, yeah, your polynomial, what is it saying when can I do submit, is that okay?
Yeah, you can like unfold it if it's easier.
Isn't a variable equal to the formula?
Oh, that's the one I emailed you about.
Oh, wait, when did you email me?
Like, I think in the weekends and then,
Did I respond?
yeah.
Oh, wow, that's amazing
You
too.
didn't give-
Okay.
You didn't give me credits on that, but it's also shows that kind of wrong thing. It didn't accept my answers.
It didn't like your answer either.
Yeah.
Would you just shoot me a little email and I'll check out what it's looking for, Grace and Vivian. Just somebody send me an email saying web work number 5. You don't have to do anything detailed, and I will get on that and help. Yes, Ella.
I have a question about the written problem set.
Yes. Yes.
So it's the first problem, and we're finding a general solution for each equation. It's
Yes,
what we
ma'am.
were kind of doing
Yes.
last class period.
Yeah.
So I'm stuck on once you get the roots, and I'm not sure if these roots are right,
Yeah.
but then this is where I got tripped up was the general.
So that's what I want to start now. Let's do an example of the whole process for particular and homogeneous solutions, because I feel like that it all was at once and it was overwhelming maybe. So, let's do a mass spring system. So, x double dot plus, undamped mass spring. 4x equals, and this is kind of like the one Ella is asking about. Did I give initial conditions on that one or not? That's great. That's really fucking good. But let's do it. Let's make it terrible. So then x dot at 0 equals 1. So I have a mass spring system. It is undamped. So let me just refresh this, because I really want you to understand mass spring systems. We're about to go into a bunch of just like analysis of different scenarios. So remember the equation I derived looked like this. And I'm going to complicate it just a little bit. So this is the mass of the weight. Remember, this all came about because we had a mass on a spring. And the spring has spring constant K. So the larger K is, the stiffer the spring is, and the more force it takes to to move the spring. Like a really weak spring has a very small K. So let's label some things here. So this is the mass, this is the spring constant. This is the friction coefficient. So this is like friction coefficient here, I guess. This term only shows up if we have what's called a damped mass spring. So you've got this, but it's in a vat of goo or something like that. And then this is external forcing. So what does that mean? That means there's something like maybe a jet of air underneath here. I've got this little like puffer that's on a timer. Like for this one, I've got a force that's acting like this. I've got some external force on this thing that's acting like this. That's sine of 3x. So you're interjecting or injecting some additional energy into the system. The way I'm doing it here is I'm doing it in a very chill way. In fact, actually, let's change this. We don't even need to do anything to the beginning because we're going to start forcing the spring. It should start moving on its own. So this thing here, I see no damping. Let's see, so this is an undamped mass spring. And I can think of it that way. Even if I didn't know that, I could totally think of it that way and see if my solution makes sense. Like that. So down here, I've got this little puffer of air, and it's either pushing or pulling. Maybe it actually can vacuum too. So like it's pushing, well, let's see. This is the positive direction here, and this was the negative direction. We were thinking about positive being extension, negative being compression. So this thing actually kind of draws down on the mass. It's like got a little vacuum. It maxes out here, and then it starts to diminish the vacuum and turns to a jet of air that's pushing up on it. And this continues forever. So what's going to happen? Like if I asked you the question, what is the max? Let's actually answer this question today too. What is the max extension of the spring? Of the mass. Let's just say mass spring. One is the same as the other. Looking at this, I have no idea. So we got to come up with a solution. So step one, and this is going to help you get all those problems in. Step one is to find the homogeneous solution. And actually, I have a better solution. Let's do a more meta thing here. Find the roots corresponding to each side. So corresponding to each side. And so the right side is this game we're playing here, and we played a lot last Wednesday. The left side is characteristic polynomial town. So let's do the left side. Left-hand side, characteristic polynomial. Ooh. Yes. Lounger. Yeah, absolutely. I am absolutely a fucking genius for sitting on this chair. So, what are the roots of that? I hear a T sound, and that sounds good. Lambda equals what? Plus minus 2. 2i. Think difference 2 squares, but with a positive in front, right? And if you were going to factor this, here's what it would factor like. It's plus or minus. This is lambda minus positive 2i. This is lambda minus negative 2i. Do the FOIL, you get that back. Lots of ways to see that, but is there anyone who needs me to tell another way to find that? Let me know. Hans.
Okay, so this is something I was confused about on the homework.
Cool, let's talk.
I just, like the eyes. What's going on with the eyes? Why do we have them?
Wow, I did a spit take for real. Cool, I like it. I like the way you put that. All right, so can you say a little more about what you mean there?
So, because I guess I think it has to do with the roots, and the roots confusing me. Because I can understand that this is supposed to be the root, but I'm unclear about why the imaginary number is necessary.
Oh, okay.
Because if you would have factored lambda minus 2 and lambda plus 2, you would have ended up with that equation. So
Ooh,
why add the i's?
Let's try you and me together.
Oh god.
You know, you know how this is gonna go. All right, so Hans, we foil, right? So first times first.
Lambda squared.
Yes, sir. What's my outer?
You'd have plus 2 lambda
Beautiful. Inner.
minus 2
I
lambda
love it.
minus 4.
Is that the
Never
same?
mind.
Not same, right?
Not.
So here's why I need the I. Let's talk about that. If I put that I there, now all of a sudden, now I'm gonna have an I here and an I here, and those still will cancel. Does that sound right?
Mm-hmm.
But out here I'll have an I squared, and that turns to a positive one, a negative 1. So I squared is negative 1, and that makes that a plus 4.
Okay.
Does that help a little bit?
Yes.
Okay. 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 Any other questions? That was an awesome question.
So if there's an addition of roots, like, is it just going to be like the same thing except with I? Like,
Let me say that again.
if there's an addition of squares, it's the same as like a difference of squares?
Yeah,
It's just
yeah,
gonna be
yeah.
I.
Yes, exactly. Yes, so lambda squared plus something positive always has lambda minus root positive I and lambda plus root of that number I. Yes, exactly. Difference of 2 squares, just an imaginary one. Beautiful, yeah. Other things. Ella.
I understand how to find the roots if it's a problem that's set up like that to where you can see where the eyes are coming from really easily, but like when the equation is more complicated,
Like-
it can't be factored easily.
Yeah, like maybe you'd see something like that, right?
Mhm.
Like, let's say, how would we factor that? So this is the kind of thing I think you're thinking about. This has imaginary roots, but it's not obvious at all what they are. So what I would do, Ella, is imagine it's equal to 0. Hopefully you end up with a quadratic. That's probably as bad. I wouldn't think, you don't worry about anything else. Because if there's higher powers, you can probably pull them out and stuff like that. So the quadratics are where those imaginary roots are gonna come from. So I would go to the quadratic formula. Right? So this is your friend, Ella. This will never let you down. No matter if you know how to factor or not, there's your roots, right? So in this case, this is where we have A equals 1, we have B equals 1, and we have C equals 1. So lambda here is going to equal negative 1 plus or minus root B squared minus 4 times 1 times 1. I'm going to get a negative square root over 2. So that's going to be negative 1/2 plus or minus square root of negative 3/2. And square root of a negative, you can pull the negative out as an I. So you make that square root of 3/2 I. And see, I could do that over here, so let's do that over here. If you don't see it, and that's okay, you don't need to see it, because you've got the quadratic formula to save you. So here, what does B equal, Ella? So I've got A is 1, C is 4, what's B?
0.
Yeah. So I got 0 plus or minus root 0 squared minus 4 times 1 times 4. Does that make sense?
Mhm.
Okay, cool. Over 2 times the leading coefficient, so that's plus or minus root negative 16 over 2. That's plus or minus root positive 16i. I pull the negative out, it's square root of negative 1, right? Because this is just. So I pull that there. Over 2, square root of 16. Simplify. Quadratic formula. Yeah? Other questions? These are all great. This is all great stuff we need to know to do this stuff. All right, beauty. So let's keep cruising. So I got the roots. That was for the roots of the left side. That was fun. literally the only lecture I'm ready for. I'm so happy to be here because I feel prepared. There's this, I was talking to one of my calc students and I said, God, that was a shitty lecture. And he's like, oh, I thought it seemed pretty good. And I was like, I knew better. And I was feeling it the whole time. So, okay, so my roots on the left are plus or minus 2i. What roots correspond to the right side? Plus or minus 3i. Can I talk about that? Let me look at you all.
If it was x sine 3x, would it be 1 plus or minus 3i, or 3i multiplicity 2?
Second,
Okay.
to get the 1, so your question, would it be 1 plus or minus 3i if I had that in front? The e's give the real part. Does that make sense? Awesome. Other questions on that?
So since it's plus or minus 3i, but there's no cosine in the original equation, why is that?
Because it has a 0 in front of it. We just don't
Okay.
see it. It's always there.
Yeah.
It just, yeah.
Okay.
Good question. Labine, oh, there's a question brewing. Yes,
So if it's x sine 3x,
like this? Yes.
then that x would be 0 multiplicity 2?
No, because it's time. If it was x plus, if it was x
That's what I
plus.
was getting at.
Ah, yeah. So if I had an x in front of this, it would be multiplicity 2 of this. Whatever the x touches, it's giving multiplicity 2.
Okay.
Yeah, awesome. Oh, this is so good. It's so good. Hans moved up. Holy shit.
That was so quiet.
Well, it's on camera, so.
Oh, you guys are making me. This is great. Did you have a question, Hans? Because it looked like it kind of.
No, I believe you and I'm following.
Okay. The 2 essential ingredients. Okay, great. Wonderful. So, step 1, find the roots for the left side. Find the roots for the right side. Write them out. Okay. Step 2 is construct the solution, the initial solution. So I'm going to do XH, homogeneous. That's based off the left-hand roots. And I'm going to do X particular, which corresponds to the right-hand roots. So this is left-hand side, this is right-hand side stuff. Now hopefully you've gotten a little practice and it's not going to shock you if I say this corresponds to a cosine of 2x and a sine of 2x. With no e's in front. I'd need a real part to get an e to the x sine of x and stuff like that. So this is just beautiful like this. So we got that, we're done. Now, when you go to the right-hand side, pretend like you just keep writing XH. Pretend like you're continuing on counting multiplicities. It isn't gonna matter here, but it's gonna matter in the minute when I do another example. So here, this is my first occurrence of plus or minus 3i. That's great. So that means I have a cosine